Okay, good morning, everyone. In today's lecture, we'll start with the new topic, which is measures of central tendency, and the first one is mean. Am I audible?
Yes, sir.
Yes, sir.
Yes,
Yes.
sir.
Okay. So, as I said, what we are going to study is the measures of central tendency. So, what do we mean by first of all the central tendency? We have seen three types of distribution for now. Uh, So the data may be collected in a raw form. So the data can be raw data. So in this, say 5, 15, 12, 13, 8, 8, 7, 6. Okay. So just the entries are collected. So this type of data is the raw data. Then there is a discrete frequency distribution that we know, discrete frequency distribution. And the grouped frequency distribution. Grouped or continuous frequency distribution. So what do we mean by discrete is we have certain variable x and we have the frequency around it. So I'll have 0, 1, 2, 3, 4, 5, and 0 marks 3, 1, 1, 5, 8, 7. Okay, and the uh, the last one is where you have this continuous frequency distribution of continuous variable. In this you have the class intervals and you have the frequency. Okay, so if you look at these two things, this data can be given in this form or it can be given into class interval form, the grouped, or what we say is the frequency distribution of continuous variable. So what do we observe is on x-axis, I'll just take this discrete frequency distribution here. In the discrete frequency distribution, 0 is here, 1, 2, 3, we have 4, we have 5. Okay, and depending on this, what I can do here is I can plot the frequencies on the y-axis. And once we plot the frequencies on y-axis, what I want to think of, what is the central tendency? What happens at the center of this data? So in many of the cases, what happens is uh, there is a small frequency at the start, then there is a high frequency at the center of the data, and there is again very low frequency at the end. So what's our task is? So our task is right now to identify what is the central tendency of the data. Is there high frequency at the center? Is this kind of things we need to look at, and the first measure of the central tendency is the mean. So what is the formula for the mean in the first case? Anyone? The raw data, if the data is in the raw form.
Sum of the outcomes upon total number of outcomes.
So that is the what you can say, the basic definition of the mean which we use for the raw data. So I'll write it down just in the systematic form. So for ungrouped data or individual observation, so definition mean which is also called as the arithmetic mean. Arithmetic mean in bracket AM or mean is the sum of observation, is sum of observations sum of observations divided by the number of observations divided by number of observations. So this is the most basic definition of the mean. The same definition, depending on the different what you can say environment, we change this definition formula actually. So the case one, I will write it down here. The case one that we were discussing, the raw data, if it is the raw data, which is also called as the individual observations or ungrouped data or ungrouped data. So if x1, x2, till xn are n observations, n n observations. So by definition of arithmetic mean, by definition of arithmetic mean, will have x1 plus x2 plus up to xn total divided by n. So arithmetic mean is denoted by x bar. So this is also equal to summation xi. Look, this is the notation we are coming across for the first time. This is the notation for mean. So whenever I write down this summation, it will mean that I just want to explicitly say about it, even if you are knowing this. So when I say summation I is running from 1 to n xi, so it means that you have to vary I from 1 to n and you have to add them. Okay. The second type of discrete frequency distribution is to the discrete frequency distribution. What do we mean by discrete frequency distribution? You have certain values of x, and for each value of x, you have certain frequencies over there, and this is how discrete frequency distribution is defined. So suppose x1, x2 dot till xn are the values or observed values with f1, f2 up to fn as the frequencies respectively. By respectively, I mean that for x1, the frequency is f1, for x2, the frequency is f2, and so on. So, anyone knows how do you give the mean for this? Yep.
Summation xi fi upon summation fi. I
Uh,
from 1 to n.
can someone explain why so?
So, should I explain?
Yes,
Can
sure.
so for x1 is with frequency f1. So x1 occurs f1 times. So the value of x1
Exactly.
should be taken f1 times. So we take the
Yes,
summation and divide by number of frequencies.
exactly. So, this formula is one and the same like the previous one. So what you were doing, you had n observations, you added all of them and divided by the number of entries. But in this case, what we mean by x1 and the frequency f1 is x1 is the observation which is repeated f1 times. So either you add x1 f1 times or you multiply x1 with f1. This is going to be one and the same. Then plus x2 f2 and so on. I'll take xn fn minus what will be the denominator?
f1 plus f2 plus f3 up to fn.
Yes, so we'll have f1 plus f2 up to fn. So this formula can be written as summation xi fi upon summation fi. What are the I is running from 1 to n as there are n entries 1 to
Sir,
yes, yes. Saurav, you have anything or I should go
sir,
ahead?
he left the meet.
Okay, fine. The third type of frequency distribution, the continuous one. So in the continuous frequency distribution, continuous frequency distribution. What do we mean by, first of all, the continuous frequency distribution? The ones which involve the class intervals. So we have the class intervals and we have the frequencies. Say class interval 0 to 10, 10 to 20, 20 to 30, then 30 to 40, and 40 to 50. And we have certain frequencies there, say 2, 3, 8, 7, 6. Yes, anyone? This is again something that you know. No one?
I know there are a few ways, but I don't know exactly. I can't remember them.
Anyone else? The point is, whenever a class interval is there, and what we do is we consider the corresponding frequency at the class mark. What do I mean the class mark? Class mark is the central value of that interval. So at the what I'm going to do is I'll consider this frequency to add the 0.5, and 5 is the class mark of the interval 0 to 10. So correspondingly, I will get the class mark for each and every class interval, and the corresponding frequencies I will consider at those class mark and use the same formula that I did earlier. So what I will have the class mark, which is denoted by xi. So 5, 15, 25, 35, 45. And then I'll do the calculation. These are the xi's, so summation xi fi upon summation fi. So there is nothing difference in for the continuous frequency distribution. Just the point is that we use the same formula, but the frequencies are considered at the class marks of the respective class intervals. So for calculation, we make an assumption that the frequency is associated with midpoint. Then taking xn as the mid values, we use x bar is equal to summation x I fi upon summation fi. I is running from 1 to n. So there are certain properties associated with arithmetic mean. So we'll look at the properties. Look, we are spending a lot of time on arithmetic mean because it is the most important one. The laters I'll just give the definitions and we'll move ahead. Uh, the properties for arithmetic mean. The first one, algebraic sum of deviations, sum of deviations from of the observations of deviations of observations from mean is 0. Yes. Can someone explain this? What do you mean by this?
Which means that if we find the deviation, that is xi minus x bar, and do
Exactly.
that for every element, then the sum would be 0.
Yes. So the sum of it is going to be 0. So I'll just try to prove this here. X1, X2 up to Xn. These are the entries, say, for an example. And X bar is the mean for this. So the formula will turn out to be. So what I need to do is the sum of deviation. The deviation for each of the entry will be. So X1 minus X bar. This will be the deviation for the first one. X2 minus X bar, the deviation for the second entry. Similarly, Xn minus X bar, the deviation for the last entry. And it says that the algebraic sum of deviations of observations from the mean is 0. So it means that summation xi minus x bar, I is running from 1 to n, we need to show that this is 0. So this is going to be summation xi, I is running from 1 to n, minus summation I is running from 1 to n into x bar. Can someone tell me what is the second entry? What will be that summation?
And x bar,
Only Manan is speaking. Let me check out the others. Mute yourself. Aditya,
Sorry, an X bar.
no, you're there. Then why you're not active today?
Yes, sir. Sorry, sir.
Hasnain,
Yes, sir.
what happened to you today?
So nothing.
Don't be inactive.
Okay, sir.
Fine. So as we can see here in this, what will happen? It is kind of summation I is running from 1 to 10 of 3, say. Okay, so 3 being constant, and or 3 plus 3 plus, and that is going to be 10 times. Okay, so the case is like this. And whenever there is a constant, what I can do is I can always take that constant outside and get that summation. So I'll write it on the left hand side. So minus n times x bar, as I'm adding n. What about the first one?
Again nx bar from the formula of mean.
From the formula of mean, exactly. So that is going to be n into x bar. Both of them cancels out each other and we get the answer 0. So that is how we can actually prove the first one. Now, the next observation is, property is, second one. Sum of squares of deviation taken from the arithmetic mean, taken from arithmetic mean is minimum. We won't go into the details of this proof, the proof of this, but I'll certainly explain the property. So you have x1, x2 up to xn, right? And x bar is the mean. And I have a as any number. So now, if I take the deviations from sum of squares of deviations from this x bar, the deviation from x bar is going to be x1 minus x bar. Deviation from x2 is x2 minus x bar, and xn minus x bar. Similarly, if I want to look at the deviations from the point A, so we'll have x1 minus a, we'll have x2 minus a, and this is xn minus a. Now, the sum of squares of the deviation, summation xi minus x bar square, I is running from 1 to n. And we have sum of the squares of deviations from a, xi minus a. So the property says that the sum of squares of deviation taken from arithmetic mean is minimum. So if you take any point other than the arithmetic mean, no matter what are the properties of that point, so what we will have is the squares of deviation is going to be minimum for the arithmetic mean. I'll give it as a homework. Let's you try to prove this. Next one is very important. This we are going to need it every now and then till we are studying the statistics part. And
So should A belong to the set of the observations, or it can be any number?
any number.
Okay.
So the third and a very important property, a change of origin and scale. change of origin and scale. So first of all, let me just introduce you to the change of origin. To put that in a simple manner, what I will do is I have x-axis, y-axis. This is a complete plane, right? And in this plane, what I'm doing is every point here will look like xi comma yi. So what I'm doing is okay, let's not go to the two axis. Let's just take one point, one line, one axis, x-axis simply. So I have this x-axis. I have the origin here. Any point here I have xi. So what I will do is now I'll subtract a constant number a. What will happen on the right hand side? I'll giving that a is greater than 0. What will happen if I subtract a from each and every point on this axis?
It will shift to left side.
So the every point on this line will shift to the left hand side, and even the origin, the point which was a on the left, that will become the origin now, and the origin will go to minus a. Am I right? So whole of the axis is shifted. So origin gets shifted when you subtract a constant number. So xi minus a, when you subtract a constant number from each and every observation, this is called the change of origin. What will happen if I divide xi by a? Yes, anyone? Say for condition, I'll give 0 is less than a and a is less than 1.
All the numbers would increase their own values. That is the scale changes.
What do you mean by scale changes?
Earlier, if a gap between 0 and 1 would be considered as 1, but now by dividing that number, 1 goes further away and the gap increases rather than being 1.
Will it go away?
Yes, because a is less than 1, that's why, and it's in
Yes.
the denominator.
Yes. So look, in this case, if a is say greater than 1, then it will shrink the distance between 0 and 1, as he said. So if a is, say, for an example, let's take a is 2. So the point 1 here, so if I consider this as 1, later if I divide each and every point by 2, that 1 will become 1 by 2. I mean, so the distance between 0 and that point decreases. So the scale is being changed in this case when you divide. So if I have xi by h, then this is called the change of scale. Change of scale. So what we are going to see in this property, in this particular property, is what is the effect of change of origin and the change of scale. Okay, so let me just clear this. I hope everyone is clear with change of origin and change of scale. Have anything?
Sir, means during change of scale, when we subtract xi minus a, then a goes to the right, to the left side of origin, right?
No, don't get into those details. It was just understanding purpose.
Okay.
What we mean by change of origin, when you subtract a number from each and every entry, then it is the change of origin. And if you divide by a certain number, then it is the change of scale. That's it.
Okay. When we divide, it is change of scale.
Yes. And when you subtract, it is change of,
Origin.
yeah, that's all. Hmm. So if ui is equal to xi minus a divided by h, then u bar is equal to x bar minus a divided by h. Look, I'll just give a small example here. I would, because it is very important why we are doing this, and you should know why you use the change of origin and change of scale. So, say for an example, I have the entries 2000, 2010, 2020, 2030, 2040, 2050. And the frequencies are 3, 4, 5, 1, 2, and 6. So look, this there is no point in carrying forward this 2000. Okay, so what I will do is I'll change the origin as well as I'll change the scale. Say I will define ui as xi minus 2030 and divided by 5. Okay, so what will happen? So 2000 minus 2030, that will be minus 30 and divided by 5, minus 6. Then for the second one, 2010 minus 20, this will become minus 4. 2020 minus 10, so this will become minus 2. The next entry will be 0. The next entry will be 2, and this is 4. Look, finding the mean using these two columns is now very much easier than it was earlier. Am I right? Am I right?
Yes, sir.
Yes, sir.
Harshit, is it right? No, let
Sir,
Harshit Goyal answer.
Sir, is it necessary we have to take like 2030? Like, why didn't we took
No, my
2000?
question is that are the calculations easier now?
Yes, sir. They are very pretty much easier.
Yes, and what made it possible?
The UI part, the change of origin scale.
Change of origin and change of scale. So that 20, 30 that I have took, that is random. That can be any number. Okay. But the number has to be chosen in such a way that your calculations become easier.
Okay. Sir, and what did we take for, did is h is equal to 5 in this case?
Yes, h is equal to 5 in this case.
How come 5 that I didn't get it? Because it is it the class mark?
Look, the choice of a and h is up to you.
Okay,
You can take it as per your convenience to make the calculation simpler, to make the calculation smaller.
okay,
So we have 0 to 4. Now you can take UIFI and you can go for finding out U bar. So when you use these two columns, you will get U bar. There is a relation given between U bar and H bar, U bar and X bar. So what I'm going to do, U bar into H plus A is equal to X bar. This formula I have derived from this. This is the another way of writing it. So I hope this is clear to everyone. Now, why do you use this change of origin and change of scale? So sometimes it may happen that there are a lot of values, I mean large values, which is not good for my calculations. And so what I do is I change the origin, I change the scale, make the values very much smaller, and then we find out the mean. Clear?
Yes, sir.
So I'll rub this. So I'll also note that x bar is equal to h into u bar plus a, because this is the formula which is used. The fourth and the last one, you just need to write this. Let x1 bar be the arithmetic mean of first group of size n, of first group of size n 1, and x2 bar be the arithmetic mean of second group of size n2. Then the combined mean, then the combined mean xc bar is given by n1 x1 bar plus n2 x2 bar upon n1 plus n2. So we have two different groups and we need to find out the combined mean of the two groups. Then the combined mean is given by this formula. Fine. Let's solve examples now. Example. Calculate arithmetic mean for the following. Data. Observations x and frequency f. We have 103, 110, 112, 118. We have 95. So this is 4, 6, 10, 12, 3. So simple one. We'll write down x. We have f 103, 110, 112, 118, 95. The frequencies are 4, 6, 10, 12, 3. Since it is the first example, we'll go by the basic formula. What is x bar? X bar is equal to summation xi fi. I is running from 1 to n, summation fi. Look, this is the trick. Whatever number of summation and whatever entries of summation are there, the same columns you need to make. Okay, so I have summation xi fi, so I'll make the column x into f. I need summation fi, so I'll make a column of f. It is already there. What is the summation f? So that is 6, 4, 10, 20, 30, 35. Then x into f. 103 into 4, that is 412, 660, 1120, 1416, this is 285. Can you add this?
4193.
No, it will not go 4,000. It will look. This entry is 1,000, 2,000. Adding this to you'll get 3,000.
3.5.
So
Sir, it is
3,000,
3893.
3893. 3893.
389. So x bar. What is this entry now? This is summation xf. This is summation f. Okay, let's put the values and you'll get x bar here. So x bar is equal to 3893 divided by 35, and x bar is
111.
111
2285.
228. Simple, right? So we'll solve one or two more examples on this in the next lecture. Right now I'll stop here. If you have any difficulty, you can ask.
Sir, I had one doubt.
Mhm.
Sir, in the third case, I'm telling of that measures of central tendency. You told the reason that why we write xi and